So we'll go through the quiz questions for the 15.3 and 15.4 quiz. For number 1, using the calculator to find the sine of 100 degrees 56 minutes, rounded to 7 decimal places. So not much of a trick to this one. You just have to make sure that you, again, type in the degrees in minutes and that your calculator is in degree mode. When you do that for the sine of 100 degrees 56 minutes, you'll find that it's 0.9818, and then the next number is a 5 with a 3 after that, so there we have it, to 7 decimal places. Second one is a little bit tricky with the cotangent. Of course, we don't have a cotangent key on the calculator, so recall that cotangent of some angle theta is equal to 1 over the tangent of theta, or vice versa, the tangent of theta equals 1 over the cotangent of theta. So again, those are just the reciprocal identities for those. In this case, of course, we have the cotangent of theta, so it's going to equal 1 over the tangent. So cotan of theta, or I suppose I could do cotangent of 17 degrees 50 minutes equals 1 over the tangent of 17 degrees 50 minutes. And from there, it's just a matter of typing that into the calculator. And so that turns out to be about 3.108421, and that 0 is important because it shows that we went to 7 decimal places. Here we're looking using the calculator to find a missing angle measure. So for number 3, we've got the cosine of theta equals that decimal. So what I need to do is really have the equation that the cosine of theta equals this decimal. And what I do is I really do the inverse cosine of both sides. Now what that does on the left, it just gives me theta, and it leaves me with the inverse cosine of this number. And so I use the calculator using that inverse cosine of that decimal in order to find my angle theta. So theta turns out to be about 45.306367. That was an 87 at the end. So we rounded that up to 9. And here we have the secant of theta, so of course there's no secant button on the calculator. So I have to recall that secant of theta is 1 over the cosine of theta. So the secant, or so the 2.2 is going to equal the 1 over the cosine. Just doing the dot, dot, dot there so I don't have to write that whole number out. Of course I want the cosine, not 1 over the cosine, so if I flip both sides over I get the cosine of theta equals 1 over that 2.2. And so I use the inverse cosine of that number. That will give me my theta. So inverse cosine of that number will equal theta. So we'll do that on the calculator. And we come up with theta being about 63.5841175. So number 5, here's a formula that we are a bit familiar with. It's the force or grade resistance equals the weight of the vehicle times the sine of theta, where theta is the hill's grade, either uphill or downhill. In this case, they want us to find the weight if it's traveling at negative 2.6 degrees grade and the resistance is negative 181.45. So in this case we know the resistance, negative 181.45. The weight is what we're trying to find, and we know that the angle is negative 2.6 degrees. So we know everything but W, so we'd have to divide both sides of that equation by the sine of negative 2.6. That's going to equal W. So again, a little work for the calculator. They did want this weight to the nearest pound, and so we get 3,999.9. So to the nearest pound, we'd be talking 4,000 pounds. Alright, so number 6, we get into solving our first right triangle. No matter what values they give you, I recommend having kind of the same generic right triangle to draw out each time with the angles A, B, and C. Again, C has to be the right angle. In this case, they give me side A, which has to be opposite angle A. And they give me side B, which has to be opposite angle B. And of course, it's a right triangle, so angle C is 90 degrees. So I have those three pieces of information. So I need to find angle A and angle B. And of course we also need to find side C. We could begin using the Pythagorean theorem to find side C. So in that case we would have 1.1 squared plus 3.9 squared equals C squared. You can use the calculator to help a little bit with that. And we get 16.42 on that side. And C turns out to be approximately 4.1. Again, this should really be an approximation. So finding angles A and B, I will need to use an inverse trig function to do that. I don't want to use the length of side C because I just had to calculate that from my other values and approximate it. So I want to use the 1.1 and 3.9. For angle A, I could set up a tangent equation. So I would say the tangent of angle A equals the opposite side 3.9 over the adjacent side 1.1, and then do the inverse tangent of that in order to find angle A. So inverse tangent of the 3.9 over 1.1 would equal angle A. Again, have the calculator help out with that. And that turns out to be about 74.2 degrees. Now I could really just use subtraction to find angle B because subtraction won't introduce any extra error, or I could use inverse trig function to find angle B. Either way I'll get the same thing, so I think I'm just going to use subtraction. So 90 minus that 74.2 will equal angle B, because those two have to be complementary. And that gives me 15.8 degrees. Number 7 is the same type of question. Again, no matter what they give us, it's good just to start with a generic ABC right triangle. Again, C has to be the right angle. In this case, they give me side A is 3.9 meters, and angle B is 42.7 degrees. So I need to find angle A, side B, and side C. Are the three things that I need to find. Angle A might be the simplest. Angle A would just be 90 minus the 42.7 degrees. So we get 47.3 degrees there. Now since I only have one side length, I have to use trig functions to find the missing side length, or two side lengths. I have angle B, so I'll be working from there. I guess I could use angle A, it's just as accurate, but I'll just work with B since that's what was given. In order to find side B, that is, of course, opposite of angle B, and I have the adjacent side, so the trig function using opposite and adjacent is the tangent. So tangent of that 42.7 degrees will equal the opposite side, B, which I don't know, over the adjacent side, A, which I do know. So I multiply both sides of that equation by 3.9 in order to find out what side B is. And again, let the calculator do that work for us. And for that we get about 3.6. And again, that's rounded, so I don't want to use that for my other calculations. So I'll go back to the 42.7 degrees and the adjacent side of 3.9 to find the hypotenuse. So in order to find the hypotenuse there, I would have to use cosine. That's the trig function that uses adjacent and hypotenuse. So that would give me 3.9 over the C, the hypotenuse. So I'd really multiply both sides of the equation by C would give me c times the cosine. So c would really equal the 3.9 divided by the cosine of 42.7 degrees. So again, the way that works is I take and multiply both sides of this equation by c. They cancel out over here. I have c times that cosine of 42.7. So to get this c by itself, we divide both sides of the equation by the cosine of 42.7 degrees. And so that's where we get 3.9 over the cosine of 42.7. And we get about 5.3 meters for that one. So here, again, a drawing would help. Not that I'm going to really draw a flagpole or anything, but they say that the hypotenuse is 52 meters long. Now, don't ask me how they know that. They just apparently do. And the shadow is 48 meters long. The question, how tall is the flagpole? Well, it's really just a Pythagorean theorem problem. Call this side A. A squared plus 48 squared would equal 52 squared. So A squared would equal 52 squared minus 48 squared, and we'll square root that number. So again, really just a Pythagorean theorem question here. The hypotenuse is 52 meters. Don't ask me how they know that, but they do. Length of the shadow is 48 meters. They could figure that easily enough. So we set up the Pythagorean theorem. A squared plus b squared equals c squared. We would subtract the 48 squared from both sides. Get a squared equals 52 squared minus 48 squared. Turns out that a squared is 400. We square it both sides there. We find out that a is 20 meters. Certainly a diagram would be helpful for this one. So they want to dig a tunnel from point A to point B. A and B are both visible from point C. If AC is 150 miles and BC is 293 miles, and if angle C is a 90-degree angle, find the measure of angle B. So they actually want the measure of angle B this time. So from angle B I have the opposite and the adjacent, so that's a tangent function. So tangent of angle B would equal the opposite side 150 over the adjacent side 293. So I use the inverse tangent in order to get the angle B. So inverse tangent of 150 over 293 will give me that angle B. And angle B turns out to be about 27.1 degrees. And again, we're going to need another triangle here. This one says from a boat on the lake, the angle of elevation to the top of a cliff is 14 degrees 33 minutes. So it would be this angle here. This must be the boat. If the base of the cliff is 1,947 feet from the boat, how high is the cliff to the nearest foot? And of course, assuming a 90-degree angle there. So we'd have to figure out a trig ratio. Again, from the angle that we have, the side that we want to find, the height is opposite of that angle, and we have the adjacent side, so another trig ratio. Tangent of the angle 14 degrees 33 minutes equals the opposite side, which we want to find, over the adjacent side, which we know. So we multiply both sides by the 1947. So 1947 times that tangent of 14 degrees 33 minutes is going to equal our h value. And to the nearest foot, h turns out to be about 505 feet. Here we have a balloon. It's 887 feet high. Angle of depression to the ranger headquarters is 81 degrees 37 minutes. So remember, angle of depression is actually this angle here, so 81 degrees 37 minutes, not drawn to scale, of course. So that's that angle there. So a couple different choices we can have. We could use that angle to figure out this angle, because they have to be complementary. Or in this case, I'm probably just going to use the fact then that this angle would be 81 degrees 37 minutes. So I don't have to mess with calculating the other one. The question, how far is the headquarters from a point on the ground exactly or directly below the balloon to the nearest foot? So they want us to find this side. Let's call that x. So, again, if I'm working from this angle now, then I have the opposite and I want to find the adjacent. So there's my tangent function again. So tangent of 81 degrees 37 minutes equals the opposite 887 over x. So again, I would multiply both sides by x. I would cancel those out on that side, and then divide both sides by the tangent of 81 degrees 37 minutes. So x will equal 887 divided by the tangent of 81 degrees 37 minutes. And so they wanted this to the nearest foot, so I get 130.7, so the nearest foot would be about 131 feet. So I hope that quiz was helpful. Feel free to ask any questions if you have them.